Hi everyone. In this video, we are going to solve Kadane's algorithm. The another name of this algorithm is longest sum continuous subarray. So let's quickly see what does this problem say. Given an array ARR of n integer. By the way, I took this problem from a Geek for Geeks. You can also check this problem on the Geek for Geeks by typing this Kadane's algorithm GFG. So problem says given an array ARR of n integer, find the continuous subarray containing at least one number which has the maximum sum and return its sum. So it says that we have given an array. So we have to find any subarray which has a maximum sum in this array. So how we can solve this? So we have to use an algorithm that is Kadane's algorithm. So let's quickly see what is this algorithm and how we can solve this particular problem. So guys, here we have an array. Let me remove this. We have an array 1, 2, 3, -2 and 5. Alright. Here we can see that the maximum subarray is nothing but the whole array. We are taking all number, then we are getting a maximum sum. If we are take only this number, then we are getting a sum 6. Here we are taking a one number, then also we are getting 5. But if we take whole number, then we are getting 11 -2, that is 9. So we have to return 9 because this only subarray have a maximum sum. But if we take this particular example, this is -1, -2, -3 and -4, then you can see if we take any of the number, we are getting a negative. If we add negative in negative, then again we will get a more negative number. So instead of adding, we are just taking only this subarray, which is having a maximum sum, that is -1. If we add any number with it, then again we will get a more negative number. If we take any other number, that also will be the less number than this number. Let's take one more example. So let's say we have an array 6, again -8, then 4, then 5. Fine. So if we take the all the numbers, that means whole array, then the sum we are getting is 7, right? But if we take only this array, then we are getting 9. That means this subarray will give us a maximum sum than whole subarray. So we can say that the maximum sum we can obtain is 9 from this array. But we need to return only the sum. So we are going to return 9. So this is basically a problem. So now guys, let's see what will be the logic, what is this Kadane algorithm and how we can solve this particular problem. So here guys, I'm going to write logic. Okay. Now guys, I'm going to take only this example, the first example, 1, 2, 3, -2 and 5. So we have this array so far. So what we will do, we will traverse the whole array, but before that, whatever we have to return, let's say sum. So initially our sum will be a negative number which can't be present in this array. So let's see the constraint. You can see that guys, in constraint we can see that the L value of an array can't we go beyond this -10 raised to power 7. So we can take any value, let's say -10 raised to power 8. So we know that this number can't be present in this array. So the minimum number we have this so far, -10 raised to power 8. And we can also take one number that is current sum, and initially this number will be 0. Alright, so now we will traverse this loop. So we'll say 4, and here we are going to traverse from 0 to the length of this array. So let's say n. So on every iteration we will add these numbers. First of all, we are here, so we are going to add current sum plus equal to 1 is going to equal to 1. So far our current sum is 1. So let me take a new color, and here I'm going to write one variable. Let me take it, and here I'm going to say current sum initially was 0, but now it is going to equal to 1. Fine. And sum is going to be still 10 raised to 1 minus a. We'll update it, don't worry. I'm going to say current sum plus equal to 1. So I'm going to say add this value current sum plus equal to 1. Fine. Now guys, note here 1. I have to write here the value. So I can say ARR of I, which is going to be current number, right? And here I'm going to say if current sum is less than this particular value, ARR of I. So what I can do, I can say that make a current sum is equal to ARR of I. I'll tell you why. See guys, let's say our current sum so far is 9, -9, and this number is positive. So that let's say the current number is 8, but my current sum is -9. If I am adding it, then it will become -1. Fine. So it will become -1. But if I take only this number, I will start from this subarray. Then I can see that this subarray will give definitely a larger number than this subarray. So in our subarray, the so far sum is -9, but we are going to add with +8. But why? Because if we add it, then we will get -1. But if we start from this new subarray, let me write it 8. But if we start from this new subarray, then we can get larger number, this -1. So I want to just tell you that, let's say we have this subarray. And if we are starting from here -9, and we can say current sum is -9, right? And our sum is also currently -9. But if we are moving to next iteration, then why we need to add it again 9 plus 8? Because this will gonna return us -1. Fine. But if we start from this only, then we are getting a 8, which is greater than this. So I can say that if current sum, let me take it again different color. So if current sum is less than ARR of I, that means after adding, if we are getting a less than this number, So minus 1 is less than 8. So it's better to take a new subarray from that particular index. So we'll say current sum is going to be ARR of I. We are going to start now this. So current sum will take 8. And after this, let me take again a pink color. So after this, we are going to say our sum is going to be maximum of sum and this current sum. So now my maximum value, that may be sum or current sum, is going to be stored in some variable. And at the end of the loop, once it complete, we are going to return our sum. So this is a simple code. I believe you understood it. So if you still have any kind of doubt, you can write in comment section. I'll definitely there to help you. But now let's move to the implementation part and see how we can write this particular code. So here guys, first of all, what I'm going to do, I'm going to say my sum is going to be initially a negative value which can't be present in this array. So we can write either 10 is minus 10 is to power 8, or I can use a float minus infinity. That is going to give us a negative integer value. Alright. After that, we are going to say current sum, which is going to be initially 0. Fine. And after that, we are going to traverse this array. In Python, we can use for value in ARR. We can traverse by just value only. And after that, we can say that add current sum. Let me write current sum plus equal to our value. So once we have added it, we have to check if current sum is less than our value. Then we have to say current sum is going to be equal to our value. Alright. Now guys, after this if condition, we are going to say our sum is going to be update. It's going to be maximum of sum comma current sum. And let me take another variable. This sum is a keyword. So I'm going to say here result. Alright. And here also result. And here also I'm going to write result. Fine. Once this loop over, we are going to return our sum. So we are going to say return result. So I guess we have completed this. So let's see whether this is working fine or not. So by compiling and run, we can check it. You can see guys, now my first test case passed. Okay, now let's try to submit this code whether this is working fine or not. So you guys can see that problem solved successfully. That means our all test cases are passed. And also one thing I want to tell you guys, we can instead of this 2 line, 3 line, we can just write 1 line, that is current sum is going to be equal to maximum of current sum, or we can say current sum plus value and only the value. Now if we run again, just see the example. You can see that we are getting again same output 9 9. That's all in this video guys. I hope you understood the Kadanes algorithm. If you have still any kind of doubt, you can ask in the comment section. I'm definitely there to help you. And guys, if you learned something in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.